Okay, it seems that we are going live. Checking on my second computer. Yes. Okay, so we are live. So hi everybody, and welcome to this new session of Coffee Break with Eddyfi. I'm going to be your host today. My name is Frédéric Reverdy, and we're going to talk about TOFD, Time-Of-Flight Diffraction with capture on the Gekko. So I have Gekko with me. I hope you have your coffee mug. I have tea today. Trust me, it's not beer. A few reminders as usual. If you want to comment in the chat room of the YouTube live, you need to have a YouTube account or a Gmail account. Of course, we are recording that video, so it will be available just after in our YouTube channel. And you can always ask questions over there after. Here you have my email, freverdy@eddyfi.com, so you can ask questions. I'm checking if my colleague Bertrand, Bertrand is here, Bertrand Bilbao. So I don't pretend to be a top guru, but Bertrand is, so I'm hoping he's going to help me if you have tough questions about TOFD. All right, so let's switch to the presentation. So here you have a camera that's pointing toward the sample we're going to be looking at, and here is I'm sharing my screen from my Gekko. So I hope you are not seasick. I'm just going to show you the setup. So here we have the Gekko. It's a Gekko 64128, but it will be working as well with any Gekko or the Mantis. I'm plugged into the label connector. I don't use a preamplifier. Just wanted to show that I'm not cheating at all. I'm gonna have to use this smoke-up right here. This is a 1/2 inch V-weld. I don't have anything thicker than that with me due to the confinement. And I will be using this probe, 10 MHz probe. Our friends from EcoScan were kind enough to send me a bunch of equipment. So they sent me their compass, this 10 MHz probe. They sent me also a bunch of other probes, 5 meg, other wedges. So thank you guys for this. So these probes are 10 megahertz, as I mentioned, with 100% bandwidth, plus or minus 10%. They have a diameter of 3 millimeter, and I'm going to use 2 wedges, L60 wedges. All right, so let's jump into the software. So when you start the software, the TOFD part, this is where you end up. You have the specimen, the probe, and the scanner to define. As I mentioned, we are using a 12 millimeter V-weld. Here we have defined the heat affected zone, even though it's not really useful for TOFD. For the probe, we are going to be using a 10 meg probe. I'm not going to talk about filter right now. I'm not going to use any filter, even though it's usually recommended for TOFD. I just want to show you the signal quality without any filter. We're going to be using a sampling frequency of 100 megahertz. No averaging again. We'll be using it after, but here I just want to show you without the average and without filter the quality of signal you can get. Voltage of 200 volts. So my 3 millimeter diameter. I'm plugged into channel 1 and 3 conventional. I'm going to use an L60 wedge. So you can see here the 2 probes and the PCS. And this will be where you'll be doing your wedge delay calibration if you wanted to, if you have a V1 mockup, for example. All right. So the scanner I'm going to use is a string encoder, 22 points per millimeter from EcoScan as well. All right, so let's go into the PCS, probe center spacing. So this is the signal we are getting right now. This is my lateral wave. This is my backwall, and this is my mode converted. I'm not, again, using any filtering or averaging. So here this panel is getting the information from the previous panels, 10 meg, 60 degree, 12.5 millimeter plate. So what you have to do to calculate the PCS, is to position one gate for the lateral wave. So this is the green one is my lateral wave. I'm measuring the arrival with the first peak negative, and the second one is the gray right here, the gray gate for the backcore. Obviously, because of the phase opposition, I'm using here a positive gate. I just press calibration, and the system you see is measuring the PCS. So let's see if we can kind of do this a little bit. You can kind of see that here I have my 36 millimeters. Okay, I have chosen this because of the well cap, so I cannot go over it. I'm not going to use any TCG, as we don't typically use TCG for TOFD. For my trajectory, I'm going to acquire data over 145 millimeter, which is about the kind of the width of my part every 0.5. You can see here, like in a 3D, that I am moving as I pull the streaming quarter. So my TOFD is moving. For the display, nothing particular here, as the views are very simple for TOFD. Only a mechanical B scan and A scan right here. Obviously, you can configure this when you have more than one TOFD or when you have TOFD and PA. Obviously, you can combine them on the Gekko and the Mantis. And recording, so this is what you'll be defining your report. So all the information you'll be exporting into your report, obviously your name, company name, site location, and so on. All right, so let's go into inspection. So I'm going to move right here at the beginning, use a little bit of water. I'm going to connect somehow my streaming encoder. Okay, so I'm going to start from here, go this way. All right, press 0. All right, so we can see here that I acquired 100% of my data. I didn't miss any data. I would also have a black line if I missed any data. I can save the data and go into analysis. So I'm saving that to the hard drive. All right, so here we are into the analysis. First of all, just want to tell you that here the banner has been revised with the latest version of Capture 3.1. Now we have 2 banners, so that we have 4 indicators. We have another set of indicators, and you can obviously completely configure, display all kind of information depending on what you want to do. You can save them. We have a TOFD banner template that we can use with some parameters that we estimate interesting, the scan, position, depth, TOFD, Time-of-Flight, sorry, and other parameters. Okay. So here you can see the signal quality again with no averaging, no filter, nothing, just raw data. I'm going to decrease a little bit to put my lateral wave at between 40 and 80%. So this mockup has 3D effects. So I think it's pretty obvious to see the 3D effects. All right, so we're going to go into the TOFD tools. All right. To go into the TOFD tools, you just click on Analysis, and you click here on TOFD. And we have different options. You can go here into the little tab. So we can do the wedge delay and calibration. We can do the wedge delay plus the lateral wave straightening. And you can also do the wedge delay plus lateral wave straightening plus lateral wave removal. So for now, we're just going to do the wedge delay and the lateral wave straightening. For the detection type, I'm just going to use a first flank. I'm going to use my positive. I'm just going to set a threshold. So let's put a smaller threshold right here. So you can see here I have my gate, and this is where I'm going to do measure the wedge delay and the lateral wave straightening. So I can move either on the A scan. I can also move on the B scan to make sure that I'm not going to pick any of the surface breaking defect. When I'm happy, I just press OK. well, this is, I can always pick like another scan if I want, just unactivate it or inactivate it. All right, so let's say we are happy with it. When you are happy with it, you just press OK, and then we are gonna, you can see that the scale now is obviously non-linear because we are using TOFD. It's in millimeters, and the 0 is for my 10% on the positive pulse. All right, so let's go look at the first defect. So obviously the first defect is a surface breaking defect, and let's try to characterize it. So what I'm going to do is, as I selected 10%, I'm just going to go on 10%. My cursors, all right, kind of, okay, good enough. And I'm just going to go right here. So right here, I'm at the beginning of my lateral wave. So what I'm going to do is I'm going to bring the reference cursor, my blue cursor, along the depth right here. So now my blue cursor is right here. It's aligned with the lateral wave. And I'm going to try to measure the height of the defect. So now I'm going to move my data cursor. You can see the hyperbola. And I'm going to look for the lowest point, which is kind of right here, for the deep diffraction. Okay. So, and this is the same polarity, and I'm bringing my measurement cursor. So here already, between the blue and the green, I have the height of my crack. Then I'm going to move to the scan, and I'm going to look for the shape of my defect, kind of using the hyperbola. I'm going to bring the reference cursor right here. And I'm going to do the same thing for along the other side for the measurement cursor. So here I have the height and the length, and we can use this new button. That's a button I presented in our first coffee break for the auto sizing feature and the analysis feature. So I just press here, and I automatically create a box and an indication. So if I go into our sizing and our table of indication, so you can see that I have created already a first indication with some parameters. Again, I'm just going to use our template, TOFD template. I'm going to display the scan start, the length, depth start, the height, it's this stuff, and manual sizing. Auto sizing, not really useful here. So I'm just going to select it, and I can remove it. So it's fully customizable. And yeah, maybe I can take an image. I forgot. I'm just going to go back, take an image right here, and I'm going to associate the image to the first indication. All right. Okay, so let's zoom out. All right, so I already have my first indication. Now I'm going to go at the second indication. So if we look at the second indication, we don't see any disturbance of the lateral wave or the backward echo. So this is mainly a defect which is in the volume of the part, and we don't see any indication that we seem to be able to measure in height. So that would be a non-surface breaking discontinuity with a non-measurable height. So we're going to zoom a little bit as well. And same thing here. So because I'm looking, we'll try to find the height is pretty flat, so I'm pretty happy here. I'm going to look at -10. It seems to be a diffracting effect right here. So here. And again, I'm going to bring my cursor along the depth. I'm going to bring my reference cursor. Now I'm going to go here, and sorry, wrong one, along the scan, moving my cursor to fit my hyperbola. I'm bringing my reference cursor. I'm going on the other side, trying to fit the measurement cursor. And now I need to do the depth. I'm going to bring along the depth as well, the reference cursor. Okay, perfect. Okay, so here now I have my other indication. I can create an indication the same way. So I create the indication for this second defect. And I'm going to go for the third defect in my mockup. So here we can see again no really influence on lateral wave. Maybe I lost coupling here a little bit. But we definitely see an influence on the backward echo. So this is probably a surface breaking discontinuity on the opposite surface. All right. So what are we going to do? We are going to take my data cursor, and I'm going to look for the tallest point, which seems to be kind of around here. And this is the top diffraction, so I'm going to look for the opposite, it's right here. And again, I'm going to do the same. I'm going to bring my reference cursor here. Now for the height, because it's a surface breaking crack, I need to measure the back wall. So the back wall is going to be opposite as well, and I'm going to be kind of outside of the defect. So here, minus 10% on the opposite phase. Remember, I used the positive phase for my lateral wave. I'm bringing my measurement cursor here. So here I have the height of my crack. And now I'm going to go back on the scan, and I'm going to try to measure my defect. Oh, it's kind of right here. I'm going to bring my reference cursor. I'm going to go on the other side. Okay, not really good, but it will be kind of right here. And you see this is, again, I'm going to use the same tool to create another indication. We take a picture again. All right, and I'm going to zoom out. Okay, so here I have my three indications. So now we can kind of go into the analysis of the indications. All right, if I do that, I'm going to have a hard time. Here we go. Okay, so the three are defects. This is not a geometry echo. This is a defect, and this is a defect. For the comment on the first defect, so this is surface breaking. Sorry, I'm going to use SB. Same surface, so scanning surface, and it's a measurable height. Okay, discontinuity. The second one was what? Non-surface breaking, so non-surface breaking, non-measurable height. Okay, and last one was surface breaking, opposite surface, measurable height. Maybe you have better acronyms. For the acceptance level, depending on the criteria that you are using, if you are using acceptance level number 1, 2, or 3, obviously due to the length of my defects, they are all above 0.75 or even like 1 thickness, so they are all rejected. All right. Okay. This is the bad part. Okay, so now we can go into the report. Hope I'm not losing my point. Okay. All right. So this is the report. Obviously, this is, you can change everything. You can change you can put your own logo. You can customize completely the information about we have seen before. You can put the photos of all the equipment you have been using, the parameters you have been using for your ultrasound, your table of indications with the scan start, length, height, flow, rejected, surface breaking, so all the comments and the screenshot that we have been taking. So I forgot to take a screenshot for the second indication. Sorry about that. And at the end, you can add a remark. This is really a bad part. I don't like it. And then after, you can save your inspection report as a PDF or as an Excel report, which is saved into the folder of data, and you can send it obviously to the level 3 to the customer, and so on. Now, okay, so I'm creating my report right here on my Gekko. Okay, so that was kind of it for the presentation. So that was a quick presentation this time. That was a quick coffee break. So I'm going to look at questions. If you have any questions, I'm going to look at the chat room. Sorry, I have to look here. Okay, so I have a question. Does capture software take into account the direction of displacement, parallel or non-parallel? Yes. Okay, so I'm going to have to I'm going to switch a little bit here. So you know what? I'm going to actually change. I'm going to use the 5 meg. I'm going to change a little bit. As I mentioned, I don't have a lot of samples right here due to the confinement. So I'm going to use that sample right here. This is just a sample to show you the hyperbolic cursor when we have a parallel displacement, so with 3 central holes. And I kind of prepared my setup before, just don't want to go through the setup again. So L 5 megahertz. Yeah. The thing you change for the displacement is right here under the motion panel. You can see that my displacement here is in the same direction as my TOFD. So you just change your orientation from along X, X being the axis of the well, to along Y. So I'm just gonna use, it's better to plug them. Very typical, usually happens to me when I leave with phase array probes, but apparently I also do it with conventional. All right, a little bit of water. Okay. Okay, a little bit too much gain. Increase a little bit. All right, so this is my lateral, this is my backbore. I'm just gonna do a little displacement. All right, let's save my data. I'm going to go into the analysis, and you can already see the shape of the cursors is not the same. The hyperbolic cursors are taking into account the fact that we have been doing a parallel displacement. So yes, to answer the question, we can actually, the software is taking into account the direction of propagation. Okay, so Santiago, how is performance in thin thicknesses, for example, 5.56, 6 or 7 millimeters? So we have been using, so that was before, I forgot to mention the most important part, actually. That's pretty funny. Yeah, so with this version of capture, so the 3.1.1, don't forget the last 0.1, which is important. For all Gekko users and Mantis users, we have implemented a 19 dB analog gain boost in the update. So this is not a software, this is an analog gain. So you just need to update your software. No need to send your unit back, and you will get this 19 dB gain boost. So this is why that allows me to use without filters or averaging. So now to go back to your question, Santiago. So yes, we have been using 15 megahertz probes on samples, on 5 millimeter samples. Obviously, you need to go higher in frequency because of the thickness, but you can get good data on 5 millimeter. I will try to, you know what, while I'm answering other questions, I will try to find some data. Okay. So other question, what if I have to inspect parts that are thicker than 100 millimeters? Okay, so if you look at standards, like ISO, for example, or ASME, typically when you have to inspect more than 100 millimeters, you have to use more than 2 pairs of TOFD. So on the Gekko, we have, I showed you, we have 2 pairs of conventional. but we can use some of the phase array channels. Here, when I showed you the geometry, I was showing you the connectors, the UT-LEMO connectors, so 1, 2, 3, 4. Here you can actually take some of the channels, the PAUT channels. So if you have a 128 element Gekko, so either 32.128 or 64.128, you will take the channels 63, 64, 127, and 128. Obviously, you see here I'm not red because on PAUT channels, the maximum voltage is 120 volts. So if you were to use this, obviously now an averaging will be a little bit interesting because you send a little bit less voltage, even though you have a good signal-to-noise ratio and the probes are pretty good. You probably need to do some averaging if you were to inspect thicker material. I would probably suggest using the 200 volt for the 150 and the 200 millimeters and the phased array for the other ones. Let me see if I can find some thoughts quickly. I don't want to spend too much time. So that was the old version, so bear with me. Obviously there is a little bit more noise. So this was a 5 millimeter. I can do the wedge delay just to have an idea. That was not a really nice scan I did here, but that was 5 millimeter here. So this was a 15 megahertz in the old version. So now using the current version, you will get 19 dB boost. You see here I was using a pretty high gain when I was doing this experiment, but we could see the defect with no problem. Let me see. Other question. Yes, Alberto, is it possible to use multiple pairs of TOF with capture? I think I just answered that question. You have 2 pairs of TOF on the Gekko with the conventional channels. You can use an extra 2 using a splitter. On the Mantis you have 1 pair of TOF, and obviously with a splitter, so it will be a different splitter. It will be the 64 element splitter. You'll be to use an extra 2 channels. So on the Mantis, you will be able to use up to 3 pairs of TOF. So you'll be limited to 150 millimeters with the Mantis, which is already pretty good for a smaller unit. So Jesus Contreras, when you use multiple group P and TOF and you have a Gekko 6464, the P probes are 32 elements each one, so that means you use the 64 channels. That's perfect. That's good timing. So you will be using channels 31 and 32 and 63 and 64. That means that for your PA probes, you will have to use channel 1 to 30 and 33 to 62. Yes, seems that I've been answering questions. I just wanted to show you, like one of my colleagues sent me data on a 1-inch plate. We are all confined at home with different different samples. He was lucky, took more equipment than I did. So I'm going to show you data he got on a 1-inch plate, V-Weld with 5 meg. So I'm going to use the PC version of capture. Up. So this is the type of data. You can see that this is pretty clean. I'm just going to remove this. This is the 1-inch plate. You can see 25 millimeter. You can see that there are 5 defects. So I know them by heart. I believe this is they are porosities, even though like I wouldn't have been able to recognize them. Bertrand here helped me to do that. This was a wood crack. You can see a little bit the effect on backward echo. This is a lack of sidewall fusion. This one was hard to see. This is a very small toe crack. You can see some effect right here on the converted mode. And this one, I believe, was a lack of penetration here. So this is a type of signal. You can see that on a 5 meg with a 6 millimeter diameter, so there's way more energy than the 10 meg and 3 millimeter I just showed you today. There is pretty much like there is no noise at all. So really like this extra boost, this 19 dB extra boost really help the signal to noise ratio. I'm not saying you are never going to be able to need those averaging or this gain or preamplifier. Probably when you're getting into the very thick part, you might still need those. But really, this boost for both the Mantis and the Gekko is really interesting if you guys are doing TOFD. Okay, let me see if there are more questions. Yeah, I see like there is a little discussion between Bertrand and Santiago. So yes, you can use this 15 megahertz TOFD. Santiago, oh, I think I missed one of your questions. How would an inspection be carried out on a notional well with flat wedges if the equipment does not allow configuration of the scan plan with curved wedges COD? So obviously you can use COD wedges. You will still get your natural wave and your backward echo. For the scan plan, at the moment we don't have the kind of the spread that's in the plan. So you would need to use a software like ESBeam Tool or Siva or things like that to be able to see the beam spread and your coverage. Here you have the information about the intersection point at 2/3 or more if you are using thicker material. But that's in the plan for the part that you are mentioning. Seems that I've been answering all the questions during the performance. Yeah, so I think that we are good to go. So again, thank you for attending this coffee break. The video should be available soon on our YouTube page. Tony is going to maybe edit the beginning or the end if that was too long. But you'll have access to all the other videos. Also, as I usually do, if you go into our website, here you can get a lot of interesting information. This Eddyfi Academy, that's something we started a couple of weeks ago. You just have to sign up. It's free, and you can basically follow like short courses on different techniques, PEC, SEFM, TFM. It's an interesting one. I'm not pushing for end-to-end, but I am. How to do a setup for capture, and as well, we have our blog page. We try to publish as well. Well, it was published this week for TOFD. But you have very useful information from my colleagues and myself. For example, you can filter by brand. I'm just going to filter by end-to-end because I'm an end-to-end guy. And you can see like a lot about TKY weld, capture, clean wave imaging, and so on. So just go. It's a lot of information, and please, if you have questions, again, this is my email address, or you can ask questions on YouTube. All right. Thank you, guys. Thanks for having coffee or tea with me. And next week, we'll have 2 more sessions of coffee break. I don't know the topics yet, but stay with us. All right. Thank you again. Take care.